Today's video is a long-awaited second video in my series where I build my completely over-the-top multi-room audio system. In the previous video we talked about my plans, ran through the hardware we'll be using and installed some of the ceiling speakers, so now in this video we'll be focusing on what will become the heart of the system, which is this Biamp Tesira Server I/O DSP. So first up, what is this? Well, the Server I/O is a massive modular audio DSP system. Essentially it's a box with a bunch of different audio inputs and outputs. You can then configure it to do basically anything you can imagine with those. You could route any of the inputs to any of the outputs, you could mix multiple inputs together, you could downmix stereo to mono, adjust levels, apply EQs, configure crossovers, the list goes on. Basically, it's a really powerful audio processor, and we'll take a look at how mine is configured later in the video. Now, in terms of what I'm using it for, if you haven't seen my previous video, then I definitely recommend checking that out as I go into much more detail about my plans for this project. But just as a quick recap, I've installed ceiling speakers throughout the house, all running back to the main rack in my garage. In the garage, I'll then have a couple of streaming music players that will connect into the Tesira, and I'll be using the Tesira to let me route audio from those players to any speaker in the house. I'll also be connecting up to my Home Assistant server to allow it to play announcements and notifications throughout the house, and I'll be using the Dante audio over IP system to route audio from all my TVs into the system so I can also play them through the ceiling speakers. And yes, I'm aware this is completely over the top, and realistically, if you just want a multi-room audio system, you'd be much better off with an off-the-shelf system such as Sonos. This is very much a because I can type project, rather than the simplest way to do this sort of thing. So first up, let's take a look at the hardware. It's a pretty large 3U rack mount device. On the front we have a small screen, some LEDs and a couple of little buttons. All this really does is just show you some basic stats and health status about the device. You can't really do too much from this, so there's not really too much to really look at here. Then round the back is where things get interesting, since as you can see this is a modular system made up of various cards. Starting off with the stuff that every Server I/O will have, we have a mains input, a couple of serial ports which can be used to send commands to the device, and the first card here labelled SNC1, and this is a network management card. This allows the device to be connected to a network for configuration, and also allows you to send it commands while it's running, to do things like changing the audio levels or change what inputs are routed to which outputs and things like that. The network management card also has these Logic I/O terminals, and these are essentially a GPIO interface that you could use to connect to external input or output devices such as switches, LEDs or external relays, and these can be used to either allow the Server I/O to control external devices or to allow external devices to control the Server I/O. For example, you could connect an external relay or switch that when triggered would shut off the audio. Or what I'll be trying out with mine is seeing if I can use these to trigger my amplifier's 12 volt trigger terminal so I can use a Tesira to turn the amplifiers on and off, and we'll take a look at that later in the video. And then next up, we get into all the cards that are configurable, so you can configure your particular machine with the correct cards for what you're doing. In mine here, the black ports are audio outputs, and the orange ports are audio inputs. Now, technically speaking, these orange ports are special audio inputs that also contain additional hardware to perform echo cancellation. They also do standard input cards with green connectors that don't have that additional hardware. Each of these connectors is a 3-pin balanced audio connection, and they connect into these Phoenix connector type terminals here. So with each of these you have a hot connection, a cold connection, and then a ground connection. Of course, using these with balanced audio is ideal, but you can absolutely use them with unbalanced devices, which is what I'll be doing here. If you're connecting an unbalanced source to one of the inputs, you connect the ground to the ground, the signal to hot, and install a jumper wire to connect the cold terminal to ground. On the other hand, to connect a balanced output to an unbalanced device, you connect the signal to hot, ground to ground, and leave the cold floating. And then of course, each of these connectors represents just a single mono channel, so for stereo you'd need to use a pair of them. Therefore, each of these cards has 4 mono channels or 2 stereo channels of audio. And then next to all the analog audio cards, we have this DAN1 card, and this is a Dante audio interface. I'll be covering Dante in more detail in a dedicated video, but essentially Dante is an audio over IP protocol that's more commonly used in high-end live production situations. You can get all manner of Dante interfaces that connect to the network and provide various audio inputs and output connectors. You can then configure them to route audio between each other. And this all works at very high quality with extremely low latency in the order of single digits of milliseconds, so there's no issues with things like lip sync when using it alongside video. The Dante card in the Tesira is connected directly to the network over Ethernet and offers 64 input and 64 output channels. For my setup here, I'll be installing Dante interfaces behind each of my TVs and then using them to take the digital audio from the TV's optical output and send it over the network to the Tesira, which in turn will feed the audio to the ceiling speakers. I can also use Dante to send audio from the Tesira out of the Dante interface, For example, I have a Dante interface that will connect to my living room AV receiver and allow audio being played through the Multiroom system to be sent into my AV receiver over optical audio. If you want to learn more about Dante and to see it in action, I'll be covering it in the next video in this series, but that quick explanation should be all that you'll need to know right now to understand the rest of this video. Now, you may be looking at my Tesira and thinking, but you have a ton of input cards which are those weird echo cancellation ones, and hardly any outputs, so what gives? Well, this is because while this is a modular system, and if you're buying it new, you just buy it configured exactly to your requirements, this isn't exactly practical for home setup. That's because these systems are eye-wateringly expensive. Buying just the bare unit on its own is not far off £9,000, and in each card is around £400 for each of the basic input and output cards, around £1,000 for the echo cancellation ones, and around £1,800 for the Dante card. So instead of that, I picked mine up on eBay where they regularly sell for between £300 and £600, which is a lot easier to manage. However, with doing that, you basically just get whatever cards the device has in it. Of course, you could then buy all the cards you need separately, but they cost almost as much as a complete second-hand unit, and second-hand cards don't show up super often. So instead of that, I, bought 3 of them? Or sort of. For my initial plan, I picked up these 2 for around £350 each. One is full of input cards, and the other is full of output cards. And with that, my plan was to combine them all into a single machine with the correct number of inputs and outputs for my setup. Neither of these have the Dante card, so I was just going to go instead use some sort of cheap audio over Cat5 system. However, a couple of months later, I then came across a listing for this one, brand new in box for £500, and it included the Dante card. And given the Dante card alone cost £1,800 new, I immediately bought it too. So my plan now is to use this one as the base since it's brand new, and then swap out some of the input and output cards from these ones into this to build exactly what I need. When you're looking to buy a Tesira device, you may also come across a few other devices in addition to the server I/O I have here. In particular, you'll see a lot of Tesira Forte devices which do basically the same thing, but they're fixed, meaning that you can't swap out the different I/O cards. You're stuck with whatever interfaces the device has from the factory. For my setup here, I simply need more output channels than any Tesira Forte device offers, but they may still be a good option for smaller setups. You may also come across some Tesira server devices. Not server I/O, just plain server. And these are something to be very careful of if you're trying to buy a server I/O, since from the front they look very similar. However, the Tesira server doesn't have nearly as many expansion slots. In particular, once you factor in the required network and AVB cards, you're left with a single slot to add another card into. However, the server does have the ability to add up to 8 DSP cards compared to 3 on the server I/O, so you can have a lot more DSP processing power in a server, but a lot less connectivity. Realistically, the server is more aimed at users that are heavily using AVB or Dante to send audio over the network, whereas the server I/O is aimed more for setups like mine, where you want to connect analog audio devices directly into the DSP. So that was a run through of the hardware I've gone for. So what I'll do now is pop the top off of one of the Tesira so we can look inside, and then we'll swap some cards around. So now, let's pop the top off. And if you look carefully, you might see some slight differences between the screw layouts between these two units. That's because there's a couple of different revisions of the case. We have the newer one here, where the screws to open the case are on the top, 3 at the back, 3 at the front, and the older model here, where the screws are these these 3 screws on the back. And then additionally, this newer model also only has a single screw for each card on the back of the case, whereas the older model has 3 screws for each card. And this is quite a confusing layout, since the screws that secure it are the top and bottom 2 on the right hand side of the card, and the middle screw on the left hand side of the card. But as far as I can tell, this is the only real differences between the revisions, just some slight changes of the case. Internally, they're all basically the same, the cards can be moved between them and all that kind of stuff. But for the remainder of this video, we'll be focusing on the new revision, since that's the model I will actually be using in my setup. Now with the screws removed and the tops taken off, we can see the inside. And as you can see, it's all pretty empty, since most of the reason for it being this size is just to accommodate the vertical height of all the cards. We then have a power supply over here, a big fan on the front panel, and this massive board down here, which is essentially a big backplane that all the cards are installed into. Each of the I/O cards are installed in slots on the board down here, and then over here we have these 3 cards here, which are the DSP cards. That's because, unlike some competitor devices that use standard x86 PC hardware and perform all the processing on a CPU, the Tesira devices use dedicated analog devices DSPs. In my particular machine here, we have 3 of them. They're all identical, and you can configure a server I/O with anywhere from 1 to 3 of them. It just depends on how much DSP capacity you need. The more complicated your processing, the more DSP capacity you'll require. For example, each DSP card has enough memory to store a total of 150 seconds of audio when you're using the DSP to add delays to the audio. There's loads of other things that also dictate how much DSP capacity you need, but the software does give you an overall gauge showing how much DSP capacity you're currently using. I'm probably never going to need anywhere close to the capacity of all of these, but I'll see how much I actually end up using when I've got my setup completely up and running. And then finally inside we have all the cards we talked about before. To remove these, there's either 1 or 3 screws on the back panel for each card depending on the generation of the case, and then there's also either 1 or 2 screws holding the card down to the main board depending on the length of the card. Since I'm going to need to swap some of these cards out to better suit my requirements, what I'll do is I'll go way off camera, take out each of the relevant cards, and we'll do a quick run through of each of them. Okay, so what I've now done is I've taken out all the various cards from the machines to allow me to move them around. So here we have all the cards, or at least one of every type of card that I own. Some of these we'll be putting back in and using, others we won't be, but I thought it'd be interesting to still go through each of them and take a look at them. So first up here, we have the basic input and output cards. We have the SIN4 and the SOC4. And these are just the standard input and output cards. They don't have any additional signal processing or anything like that. And these are what I'm going to be using in my final solution. And then next up here, we have the SEC4, which is the echo cancellation input card. The sort of analog stage up here looks very, very similar, basically identical to the standard one, but we have a pair of analog devices DSPs, and this will be using the DSP hardware on this card itself to do the echo cancellation. So rather than putting that load onto the main DSPs in the Tesira itself, that can kind of be offloaded to these DSPs on the input card itself. For my setup, because I don't need echo cancellation, this is the sort of thing you'd use with like a microphone in a conferencing setup, I won't be using these, I'll just be using the basic input cards, but you can technically use these as input cards. There's a little bit of additional fiddly configuration options that show up that you kind of need to work around, but you can just use these as standard inputs if you needed to. And then next up here, we have the Dante card. And this is the card that I had to seek around quite a bit to get a machine that had one built in. But yeah, we have the Dante card. And then on here, we have the Dante module on a separate add-on card. And this is because Dante is a sort of proprietary protocol made by a company called Audinate, and they also manufacture all the hardware. So what happens is Audinate make this module here, this is the Audinate Brooklyn 2, and then companies like Biamp can then make boards that use that module in it. And on this there's like a sort of FPGA type thing, some flash, some RAM, that kind of stuff. And yep, that's the Dante card. The other thing you might come across if you're looking at Tesiras is rather than Dante cards, they'll have these AVB cards. And the AVB cards tend to be a bit more common. AVB is a similar idea to Dante, it's an audio over network kind of system. So if AVB is a more sort of widely available product, why am I using Dante? Well, this is an interesting difference between the two. AVB is technically an open standard, so actually it's less proprietary than Dante is. But there aren't really as many sort of devices that support it. Dante definitely has a much wider range of input and output devices and interfaces. But the main difference between them is how they interact with your network switches. Dante is just a standard IP protocol. You can use it over any sort of network switches, no issue at all. Technically speaking, it's not designed to be routable, but it'll work on a single subnet just across all your switches, no problem at all. You assign IP addresses to devices using DHCP, and they all just work. And we'll take a look at this in the next video. On the other hand, with AVB, while it does use Ethernet, it also has some sort of areas of the sort of protocol that require your network switches to specifically support AVB. And this isn't something like VLANs where basically any decent managed switch will support it. AVB support is only really available on sort of AV specific switches, switches that are designed for AVB, Biamp sells some, or some switches like the Netgear AV line. Or on maybe it is available on some very high-end switches, like some of the Cisco switches do support it, but you need to sort of have AV licenses and things like that. It's not something that's super widely available. And I didn't want to install something like AVB and then be limited to what sorts of network switches I could use. Whereas with Dante, I can just use this over my standard network. There's no consideration there at all. So that was all the sort of input and output cards I'll be using in my setup. But here's one we won't be using, and it's this one, which is the SVC, which is a VoIP interface. Now, I say we won't be using it. I'm not going to put it in right now, but I might actually play with this in the future. Because what you can do with this is put it into Tesira, connect it to a VoIP server, or use SIP, all the kind of VoIP protocols to communicate with this, and integrate VoIP with your DSP. So you could make phone calls into the DSP that would play out your speakers, or you could have microphones and inputs that are connected to the DSP routed over VoIP to external call. Really interesting stuff. I've not really played with it, but it does look really interesting. And it is because a lot of the Biamp products are designed for things like conferencing systems, so it does make sense that you have this. So this could be potentially interesting. I might play with it in the future. Of course, I do already have 3 Tesiras, so I can always set one up with this and play about with it separately from my main one that's actually doing my multi-room audio system. They also do other cards similar to this that can just connect to like a analog phone system if you'd rather use that than VoIP. The next card we have is one of the DSPs, so each of these DSP cards contains 2 analog devices DSPs, and up here we've got a bit of RAM, which presumably would support each DSP has its own RAM. Looking up the part number, it seems to be about 128 megabits or 16 megabytes of RAM per DSP, and that's what would define that limit we talked about earlier as to how much sort of audio buffer time you can have per DSP card. The final card we have here is a network card. Not really much on here you can see because it's all under heat sinks, but you've got a little Atmel microcontroller up here that I presume is handling the logic I/O connections, a little Ethernet controller down here, and this will essentially have the main CPU and brains of the device allowed to connect to the network, be managed over the network, and all that kind of stuff. So, yep, that's the network card there. So there we go, that's a massive selection of different cards I have here. So what I'll now do is go away and get all these installed into my Tesira, get it all built up to exactly how I want it to be set up when I install it, and then we'll get it up and running. And with that, we have my Tesira now built with the configuration I need. So as you can see here, we have 5 output cards and then 2 of those basic input cards. We've then got my Dante card, the network management card, and a single DSP card. This setup here gives enough outputs to connect all my ceiling speakers and also gives me enough inputs to connect a couple of media players and also the audio output of my Home Assistant server, which I'll be using to generate audio notifications. Now, you may be wondering why I'm not completely maxing this out with all the cards I have, and the reason is power consumption. I did some very basic testing and found that each basic input and output card, so the green and black ones, increases the overall power consumption from the wall by about 3 watts. On the other hand, those orange echo cancellation input cards increase the power consumption by around 4.5 watts each, and each DSP module increases the power consumption by around 2 watts. So we're not talking huge numbers here, but if I were to install each of the cards I need and then fill the rest of the slots with those echo cancellation cards, which I have tons of, I'd increase the power consumption by over 22 watts. So it definitely makes sense to be sensible with how many cards you install. So I did that testing initially just by swapping a couple of cards in and out of a machine and seeing how it affected the power consumption. But what I also did was measure the power consumption of this exact Tesira with its previous configuration we saw, and now with this configuration. Previously, it was drawing round about 80.5 watts from the wall. With this configuration here, with fewer cards and only 1 DSP rather than 3 DSP, we're now drawing 52.6 watts from the wall. Admittedly, that's without network connected, that will maybe increase slightly. But yep, does definitely make a massive difference depending on how many cards you install. So yeah, don't leave unnecessary cards in it. The power consumption really does add up. When it comes to installing the cards, there are some restrictions around where you can install each type of card. For example, the Dante card needs to be installed in slots 11 to 13. Slot 13 can only take networking type cards, and then when you're installing cards, you install input cards starting from the right hand side, then install the networking card starting from the left hand side, and then after the networking card, you install your output cards. Then any empty slots would sit between the input and output cards. This is all documented on the Biamp website, so it's definitely worth checking that out rather than just going and shoving cards in randomly. And there we go, we've now got all the ports all labelled up. So as you can see, I've printed off some labels using my Brother label printer, all kind of neatly spaced out to sort of match up with each of the connectors. And then the arrow in each label basically indicates what connectors the label applies to. So each label applies to the ports to the left of the label. So they're all labelled up, so we've got kitchen left and right, dining left and right, so on. Each of the bedrooms have left and right channel. We've got a few single channel devices as well, so the downstairs toilet, the subwoofer in the dining room, main bathroom, ensuite, hall and landing, they're all just mono channels, so they just have a single connector each. One spare one here as well, so I could always add an extra zone in without adding any extra cards. Probably won't though, think this is probably enough. And then on the right hand side we've got all the input cards, so what I've done is I've labelled up 3 of these as stereo inputs. We only have the 2 streaming media devices right now, but I may as well label the third up. So we've got input 1 left and right, input 2 left and right, input 3 left and right. And then for the notification from the Home Assistant server, I've labelled notification 1 and notify 1 and notify 2. Currently, I'm just going to connect a single line out of the Home Assistant server into one of these, and that will work fine. But I'm going to see if I can mess about maybe with the Home Assistant server's Linux audio config, and maybe see if I can have almost 2 separate outputs, so I can have 2 separate notification inputs on this. So maybe I could have a notification going in one room, but then a separate notification in another room. Probably not necessary really, but maybe if there's a situation where I want to maybe play sounds for like, along with button presses on a remote control or something, I maybe would want multiple outputs that could kind of work in parallel. So just preemptively labelled that just because I already had the card in there. So yep, that's all now labelled. So time to get this in the rack, get it fired up. I've got a lot more configuring to do, and then we'll jump in and take a look at the software side of things. So now it's time to install the Tesira. And to do this, I've had to make up a bunch of different cables. So what we'll do is we'll run through each of the cables I've built, talk about them, and then we'll go and get it installed. So as I mentioned earlier, to connect cables to the Tesira, you use these Phoenix connectors here. And of course you could probably find specialists who maybe make cables up like this, but generally speaking the easiest way to do it is just make the cables up yourselves. So that's what I've done here. This cable here is an output cable, so this connects an output from the Tesira into my amplifier. My amplifiers use RCA inputs. It would be nice to use some sort of balanced input, either XLR or some sort of screw terminal, but the amplifiers I've got are really good for my setup, but they're RCA, so that's what I'm stuck with. So I've got here, I've got a cable that goes from Phoenix connectors to RCA. On the Phoenix connector end, because this is an output, all we need to do is connect the signal to the plus, the ground to the ground, and leave the minus connection disconnected. We then run that down into the RCA connectors here, and I went a bit overboard and ended up heat shrinking everything, so we've got the zone heat shrinked on that end, and then on the other end I've kind of got a shorthand code to represent the zone, and then also marked the left and right channel, just because I can really. Looks quite nice. So that's the cables we're using to output audio from the Tesira into my amplifiers. And then I've also made up these single channel versions for rooms that only have one speaker, so mono zones. So this one's for the hull and landing, so we've got one end labelled there, hull, landing. Other end there, HL. Same thing, it's just a single cable rather than two. Then to connect my source devices, I've made up these cables. So all my source devices use standard 3.5mm stereo jacks, so that's what I built this cable for here. So we have a 3.5mm jack on one end, and then it comes down to two Phoenix connectors. And then because this is an unbalanced source feeding into an input on the Tesira, what we need to do is we connect the signal to plus like before, ground to ground like before, but then we also put this jumper wire between ground and minus to connect the cold connection of the balanced connection to ground. So that's the only difference there, is you need to connect minus to ground. And once again, all heat shrinked up and labelled to be a bit over the top. You can tell I just got heat shrink from a label printer and wanted to play with it, but yeah, the end result does look very nice. Then to make each of these up, all I did was buy pre-made cables, cut the ends off, and then wire them into Phoenix connectors. So for the RCA cables, I bought RCA to RCA cables that were double the length I needed, cut each of them in half, and then wire the Phoenix connectors on the middle, so there's no real wastage at that point. You kind of got double use out of each cable. And then for the 3.5mm cable, what I ended up doing was just buying a 3.5mm to RCA cable, cutting the RCA ends off, and wiring it into Phoenix connectors. Realistically, for this for using a 3.5mm jack, you would kind of need to get something that splits out to something like RCA. If you've got a cable that was just 3.5mm to 3.5mm, the problem is that on the end that you need to go into the Tesira, you need to split it out into two separate plugs, whereas a 3.5mm to 3.5mm cable is generally just a single cable, whereas this sort of has two cables that split off into two connectors, so it just works out easier to wire up if you use that type of cable. Then when it comes to terminating these connectors, I found a bit of a useful tip here, and that is that these connectors have this strain relief on them. However, it's got a weakened spot here, presumably to let you break it off if you don't want it, but it flexes on that point. So what I've deliberately done when I've wired these is I've cable tied the cable so there's a nice loop of spare wire here sort of bent up and down again. So it means that if the connector does bend and the strain relief bends, there's plenty slack wire there to allow it to bend. When I previously did this, I was just wiring them straight in and had them tight, and I later found that a couple of connectors broke off because what was happening is the wires were so tight in that any bending on the strain relief was tugging on the connections into the screw terminal and snapping the wire, so this kind of stops that. The other bit of advice to give when you're buying cables for a project like this is to buy them from a reputable supplier that provides data sheets for the cable that explains how it's constructed. So how many copper wires, how many copper strands there are, how thick each strand is, and how they're laid out in the cable. Is it a sort of coaxial cable, or is it just two separate wires in an outer jacket? So for my cables here, I went to CPC, who have all these cables. That's the two-part numbers there of the cables I went for. They're fine, they were cheap enough. And at least they had proper data sheets that said they were pure copper, and they were reasonably thick for a basic cable. What you don't want is something really, really thin and flimsy that's really hard to get into those screw terminals, or just has so few wires that they just end up snapping off. And a good example of what happens if you don't do this is this cable here that I bought on Amazon for this project. I just needed an extra 3.5mm cable before I bought these ones and bought this one, and it was actually double the price of these ones from CPC. And it's just absolutely junk, so each wire is just kind of two separate wires. There's no sort of coaxial or shielding or anything like that. There's probably about 5 copper strands in each wire, and I'm pretty sure they're copper-clad aluminium because when you twist them together, they just barely twist and they just snap off. It's an absolutely terrible cable, and for added fun, the reason there's sort of Sharpie on the red and yellow wires is because actually the polarity is reversed from what it should be. So yeah, this is absolute junk. So I would definitely recommend going to a reputable place where you know how the cable is constructed versus Amazon when you're getting some sort of weird unbranded cable with dubious construction that just becomes an absolute nightmare to terminate. The final bit of advice for cables is don't necessarily go and buy the thickest, nicest quality looking cables. Because initially I bought a bunch of these ones from CPC that are pretty nice quality, very good cables. They're definitely a lot better shielded than the ones I ended up going for. But with these ones, the actual inner core, the inner copper of the inner piece, is about the same thickness as these much thinner cables. but because the cable is so thick, especially this outer sort of the dielectric around the inner signal conductor is so thick that you can't bend a nice loop into it at this connector. And this is where I had that issue with it snapping off, because the only way I could do it is have the wire coming straight out and into the connector, and then any bending on that just cause it snap off. There we go, just snapped it there. So with this, almost with these types of connectors, I'd recommend not going for some super thick, hard to bend cable, because you can't really do anything without to sort of put strain relief on that. You're actually probably better off with a much thinner cable like this one. And then the final cable I have for this is this one here that I'm going to be using to connect my amplifier's trigger inputs up to the Tesira's logic outputs to let me use the Tesira to turn the amplifiers on and off. My amplifiers support a 12 volt trigger, so essentially it's a 3.5mm jack that when you provide 12 volts to it, the amplifiers power on. When you remove 12 volts away, they wait a few seconds and then they turn off again. So I needed some way to trigger that from the Tesira. And of course the Tesira has the logic output, so we can just connect something to the logic output and use that to trigger the amplifiers. However, the logic outputs on the Tesira are 5 volts, whereas the amplifier needs 12 volts. So all I did was pick up one of these cheap 5 volt, 12 volt cables from Amazon. Originally it was a USB connector on this end, so I just cut that off, wire it into the logic output on the Tesira. It then comes to a DC barrel jack here, and when you provide 5 volts to this end here, you get 12 volts on this end. Then to connect it into my amplifiers, I just got this cheap little DC to 3.5mm adapter. Of course, I could have just cut the end off and soldered it. This was just easier to get up and running, and this works. So I provide 5 volts out to the Tesira here on one of the logic outputs, get 12 volts here, and it turns the amplifiers on. There's only a couple of little bits of advice I'd give around this. The first one being that the Tesira's logic outputs have a 10 milliamp limit. And I'm not sure whether this is a limit that they're currently limited to 10 milliamps, or if you draw more than 10 milliamps, you might damage it. I can't really find any information on that. So I'd recommend making absolutely sure that whatever setup you go for draws less than 10 milliamps before you connect it to the Tesira. So all I did here was connect this to a regular 5 volt power supply, plug it into both of my amplifiers at the same time, check the current at the 5 volt end, and this setup here draws around 8 milliamps, so I'm fine with my setup here, but it's definitely worth checking. I also noticed that some of these converter cable things, some of them have LEDs in them, and I deliberately avoided that because an LED could easily draw just enough current to put me over the edge, so I'd also recommend if you're buying one, look for one without an LED. Then the final thing to watch out with these cables is watch out for ones that have a USB-C connector, because some of them, rather than having an actual converter that converts 5 volts to 12 volts, are designed to be used with a USB-C power delivery power supply where the cable will tell the power supply to output 12 volts, and they don't actually have any voltage conversion. Of course, some will use USB-C and will have voltage conversion, you'll be able to see that, but if you go with one with USB-A, that's a much safer bet because it will have to take 5 volts and convert it to 12 volts. And then the only other one to watch out for is some of them, rather than having a converter in the middle of the cable here, have the converter integrated with the USB-A connector. You'd probably want to avoid that because it means you couldn't cut that connector off, whereas because it's had a normal USB-A connector, I cut that off, wired it into the terminal block there, and we've got an amp trigger cable. So that's some of the cables I'm going to be installing there. Now I'll run into the garage, get it all wired up, and we'll take a look at the finished setup. So there you go, we have the Tesira installed in the rack there, and then below that we have my 2 amplifiers, and then the amplifiers are connected to all my speakers up the top of the rack using this patch panel using these speak-on connectors. And now we can see all the connections at the back of the rack. So we have all the outputs from the Tesira coming out here over these cables we looked at before. They then run down into the amplifiers using those RCA connections, and then the speakers are connected to the amplifier using these screw connections over here. Of course, I've not got all my zones connected up yet, so there'll be a lot more RCA cables coming out of the Tesira and also a lot more speaker cables coming out of the amps once I get them all installed. Then on the right of the Tesira we have all the inputs. We have 3 different input channels, 2 of them are media players, and then 1 is my notifications from Home Assistant. I set up Home Assistant to have 2 separate notification outputs, Notify A and Notify B, so I can have 2 notifications playing at the same time. Whether I'll ever use that or not, or just stick to having 1 notification channel, we'll see, but I've connected them both up. Then, when it comes to connecting all the media players up, my original plan was to use these Arylic S10 Plus media players. And these are really good little things, they're really cheap, and they can support Spotify Connect, AirPlay, and all that kind of stuff, and they're absolutely brilliant. But I'm trying something a little bit different that actually is working really well. So up here we have my Home Assistant server, which is based around a little Intel N100 motherboard, so it's a standard PC motherboard. And of course it's got onboard audio that we can see over here. When I first looked at this, I saw the standard connections you get on a motherboard, so line out, line in, and microphone, but turns out that they're actually remappable to 5.1 surround outputs. I then did an absolute ton of bodgery with Pulse Audio within Home Assistant to essentially set these up as 4 different sound output devices that I can use within Home Assistant. So we have 2 different outputs here, Media A and Media B. These are stereo outputs that serve as 2 separate media players, and then we have Notify, which is 2 separate notification channels. And Notify shows up as 2 separate outputs in Home Assistant. I then got Home Assistant set up with a bunch of bodgery around Lyrium Media Server, Squeeze Lite clients, and a bunch of bodgery I'll cover in my later video. But essentially with this setup here, I can play notification from Home Assistant and use Home Assistant to have two different channels for Spotify Connect, local media playback, and AirPlay. So I'm actually not even needing to use that separate Relic media player. All my audio is coming from Home Assistant. Now, it's not perfect, there's a few little bugs here and there, and it definitely requires a ton more tuning, but so far it's working really well. And when we take a look at my final video of the series where we take a look at the whole system up and running, I'll talk about whether this works or if I end up getting rid of it and going back to the Relic media players. And then back down at the Tesira, we have a couple more connections. So we have two network connections, one to the main network card and one to the Dante card. You need to connect them both at the same time. You can't sort of just run the Tesira off of one network card. So we've got both network connections there. Then for the amplifier triggering, we have that cable we took a look at before, plugged into the logic output on the Tesira. That then comes down, and on the amplifiers, it goes into the in port on the top amplifier, then a daisy chain out of that using a 3.5mm cable into the bottom amplifier. And then finally on the Tesira, we have this RS232 serial cable. And I'm using this to control the Tesira. Obviously, you can control the Tesira over the network using a telnet interface, but it's really, really fussy and complicated, and you almost need to negotiate a proper telnet session rather than just sort of throwing strings at a TCP port. I played about for ages trying to get it working with no dread and just couldn't get it working. So instead, the easiest option was just to plug a serial cable from the Tesira up and into my Home Assistant server over there. And that works absolutely fine. However, since I've done that, I've got a friend who's also got a Tesira, and he has built a no dread custom block that does in theory integrate with the Tesira properly. So I'll need to try that out, and potentially if I can get that working, get rid of this cable. But for now, I'm just using this to allow me to control the Tesira from Home Assistant. But yeah, that's a look at all the connections to the Tesira. So what we'll now do is we'll jump back inside and take a look at the software side of things. So now here we are in the Tesira software. And this software is freely downloadable from Biamp's website. And that is a really, really cool thing with Tesiras. Whereas with so many other products in this space, the software ends up being locked behind sort of support contracts, or you need to be a sort of sacred approved installer to be able to even touch the software or get it. With Biamp, that's not a thing. You can just go on the website, download the software, and if you have a Tesira, you can configure it. And I'd like to say massive props to Biamp for that. Not going down that sort of industry trend of locking things away. You can just go away, buy your own Tesira, download the software, and just use it as a completely average consumer. Now, this video isn't going to be a full tutorial on how to do absolutely everything you could possibly ever want to do with Tesira. There's loads of other videos out there. Biamp's documentation is really good, and even Biamp have their own videos on how to do certain things. So I'm not going to go into a full amount of detail on this, but what I'll do is I'll run through my setup, talk about what I've done, why I've done things a certain way, and hopefully it'll kind of give you a bit of an idea, if you're building your own system, how it can kind of be done. But realistically, the best way to learn a Tesira, if you already have one, is just set it up, connect it to the software, connect a couple of input devices, connect a couple of speakers, and just play with it. And in fact, even if you don't have a Tesira right now and you just want to kind of get a feel for it before you consider buying one, you can very easily download the software, and even though you can't actually, play any audio or test it, you can still build flows, see what blocks are in here, and work out how it all works together, and see if it's the sort of thing you'll be able to get your head around. So now here we are in the software, and what I've done is I've opened up the flow and project that I'm running on my Tesira for my multi-room setup. When you first get a Tesira, it's completely blank. There's absolutely no configuration on it. You have to set up everything from scratch. So this is what I've come up with. Now, bear in mind, I'm not an expert in this. I am the average person who's bought one of these on eBay and kind of figured it out as I went along. So there may be much better ways to do this. You may be a professional installer of this kind of stuff, screaming at what I've done here because maybe it's all completely wrong, but this is kind of what I've come up with. The way the Tesira system works is you have all of these blocks. There's an absolute ton of them. They're all available in this sort of palette up here. You have input blocks, output blocks, mixing blocks, level adjustments, filters, crossovers, source routers, delays, all this kind of stuff. And you connect all these blocks down, you put all these blocks onto the workspace here, you connect them together, and each of these lines routes either audio or logic signals between the blocks. So in a very simple setup, you'll have some input blocks, you might have a little bit of processing in between, maybe some levels or some mixers, and then they'll connect the output blocks, and when you connect all that up, any audio played into that input on the Tesira will be routed to that output on the Tesira. It's that simple. So if we run through my setup here, as you can see here we have these pink blocks, which are all my inputs. So here we have inputs 1 to 3, so in 1, in 2, and in 3, and these are those physical inputs on the back of the Tesira. If you click on one of these and look over here under DSP properties, you can see we have the device I/O section, which is the connector that is mapped to. So if we go to show all, we can see card 1, port 1, card 1, port 2, input 2 is card 1's port 3 and 4. As you can see here, each of those is a stereo input, so we have two different connections coming out and two different channels in that block. If it was just a mono input, you'd only have one of these here and one line coming out. And then below each of these blocks here, we then have these Dante inputs. They basically work exactly the same, but when it comes to picking the device I/O, it's slot 13, which is my Dante card, and as you can see in here, there's 64 different channels because the Dante interface supports 64 different channels. And we'll be covering Dante in much more detail in the next video. And then next to each of these input blocks, we have these meters. And these are just little meters you can put onto the workspace in Tesira, connect audio into them, and it literally just gives you a VU meter that kind of shows the levels. These are really useful to have put them all over the place. It's a bit like putting print statements in your code. If something's not quite working, you can open it up, look at the meters and see where the audio is being routed to, see if there's any audio not routed somewhere, and figure it out. So these are really useful to put in. So that's what we have there. Then we need a way to route these inputs to all different rooms around the house. And for that, I have this source router block. When it comes to routing signals, there's a couple of different options, and they're in this section here. You have a router or a source selector. What I've opted to do here is use a router, and essentially it has all the input channels, all the output channels, and then if you open it up, it is this basically massive big grid. And all it is, for example, here we've got a couple already switched on, so that is input channel 1, input channel 7 is connected to output 1, input channel 8 is connected to output 2. So it's just whatever one is switched on in that grid is how it's routed. Obviously this is just working on a sort of single channel basis, it doesn't really have a concept of what stereo is. So what I have here is just two of these inputs, these inputs are all paired up, so each pair of these is a stereo input, and each pair of these is a stereo output. And when you switch the mapping on, you just kind of need to map the relevant left channel to the relevant output, the relevant input left and right to the relevant output left and right, if that makes any sense. So that's kind of how I set this up here. Now, that's a little bit of a clunkier way of doing it. There is a much nicer block here called source selector, and if you put that there, you can say, right, it's 4 channels, we enable stereo, and with that, we have 4 left and right inputs, 1 left and right output, and in here you have your sources, you pick between them, and you can even go into here and give it a name like that, and pick your source. This is a much more user-friendly way of doing it, but what you need to do with this is you then need a source selector for every output zone that you have. With my setup here, I have 10 output zones because I've gone a bit silly with the setup. So I initially did use this, but I found that having 10 of these, each with 10 different inputs, just got really, really clunky and took up so much space on the sort of workspace. So I ended up getting rid of that and just using the source router just because it's a bit easier to work with. It makes the whole interface here a bit clearer. And then the output of the source router block then feeds into these TX blocks, which are called partition connectors. Within Tesira, you have a thing called partitions. You don't have to use them, but they are quite nice. Essentially, a partition is a sort of different page like this, and you can have as many as you want and route audio between them. It just allows you to break your system up into multiple different pages just to make it easier to maintain. So what I've opted to do here is create a different partition for each room, and that's probably the way you generally would use partitions, is different rooms or different areas, things like that. So what I've done here is I've created a different partition for each room. So for example, we have kitchen, dining, living room, bedroom 1, and so on. We've got the different partitions up here, bedroom 1 partition in here, and then here's all the logic for the bedroom 1 partition. So we'll talk about that in a second, but on the topic of inputs, we've got these inputs here. There's one more input section we haven't seen before, which is down here for notifications. So as we saw when I set up the Tesira, we have 2 inputs labelled Notify 1 and Notify 2. And those are connected to Home Assistant, so my Home Assistant server can play notifications into the Tesira. So this works in a very similar way. We have the notification inputs, a bunch of complicated stuff here we'll talk about in a minute, and then the 2 notification inputs come into this Notify routing block. Very similar idea, 2 inputs, one for Notify 1, not one for Notify 2, and then an output for every room, and then we can just map different notification inputs to different rooms. So yeah, the key thing to bear in mind there, we've got the inputs here, and we've got both inputs from the sources, which is the media that's playing, and inputs from notifications, both of which are being routed out to the individual partitions for each room. Also, I notice I'm saying room and zone interchangeably here. They are basically interchangeable. It's an audio zone, but for me, each zone is a room generally. So now let's take a look at our partition. So here we have the one for bedroom 1, which is going to be the simplest type of partition we've got. We have my 2 source connectors, so our partition connectors, we have source in and notify in. These are mapped directly to these blocks here that transmit data between partitions. So we can double click on this here, and as you can see, we're just mapping the transmitters, which are on this tab here. These are transmitters. We map those transmitters to this particular receiver here. And these are all available under the partition connectors block here, Audio TX and Audio RX. So the selected source for this room is being sent into this source in here, and any notifications that are sent to this room come out of this notify in block. We then have a level block. This is just a volume control. So we can come in here and that lets me adjust the volume of the source playing in that room. And then separately, I have a volume control for notifications. We then have this magical auto ducker section here. We'll talk about this in a second. And then all we do is we pass the source and notifications into this. We get a stereo output, which is what's going to go off the speakers. They then come up here. We have another meter. This again just lets me see the levels that are playing in that room, check the audio is being routed correctly. And then we have bedroom 1 out. And this is mapped directly to the output on the back of the Tesira. So that's kind of the basic flow we've got set up here. Now let's talk about this auto ducker thing that I've been kind of skipping over because it's going to be really hard to explain because it's a bit of a bodge I kind of put together. So with my setup here, I want the ability to play notifications in different rooms. And what I want is if, say, I'm playing music in a room, I don't want the notification to kind of just play really loudly over the music in a way that you can't really make it out. I want to do what's called duck, where I gracefully turn the music down, play the notification, and turn the music back up again. And it should do that really sort of nice and smoothly, so you kind of hear the music turning down and go, okay, maybe a notification's coming in, notification plays, and then the music gracefully comes back in rather than suddenly cutting back in really loudly. And similarly, when the music's ducked down, it isn't completely removed, it's just turned down to a very low level. Now in Tesira, you have a thing called a ducker block. It's very simple. You put the ducker block on, you give it a channel, you can give it 2 channels if you want a stereo ducker, you send your audio in, your audio out, you can then switch it on and off, and when it's switched on, it'll dip the audio down, when it's switched off, it'll bring the audio back up again, and you have an attack and release time, which is how quickly it'll dip the volume down, and how quickly it'll bring the volume back up again. And then on these ducker blocks, you also have this sense input. This lets you automatically trigger the ducker if audio is present. So with my setup here, I would connect my source into the first 2 channels here, the output will go to my speakers, and I can connect my notification input to the sense input. And what that would do is whenever there's a notification, the notification will trigger the sense input, that'll cause the ducker to come in, and then when the notification is finished, the sense input will stop receiving audio, and the ducker will release, and the volume level will come back up again. And then you also have this option here from mix sense. What that does is any audio played on the sense input will get mixed into the output. And that generally does work, but the downside with that is that the notification will play immediately before the ducker's had time to completely bring the volume level down. Now, if you have a very fast attack time here, so the volume cuts immediately and the notification plays, that would be fine, you wouldn't really notice it. But with my setup here, I'd much rather have a nice smooth transition, so the volume starts to dip down, then the notification plays, then it comes up, and it's a nice long, slow dim down you get of like maybe half a second or a second or so. The downside of that is the notification, if you use this sense input and the sense mix function, the notification will still play as soon as it's passed in, before the ducker's had time to bring the audio down. So that's where I built this thing called an auto ducker. This is created if you right click and create a custom block. Essentially it just gives you a little block here, you can put more logic in and then kind of hide it away. So it's a nice way to kind of hide complicated logic and copy that between different areas. So I've set this up here. We have the inputs, which are these 3 inputs here, and the outputs here, which are these 2 outputs here. Works very similar to as I described. We have the ducker here, so the source comes into the ducker, and then the output of the ducker connects into this mixer, and then that goes out to the room output. We then have this thing here called duck trigger, and this is a signal presence meter, so this detects if a signal is present. The notification input is fed into this signal present indicator. So with this, if there's a signal sent into this of less than or more than -50 dBu, this will then output a logic level of high. And this is because in Tesira, there's the concept of logic. Generally speaking, any sort of blocks that have connections on the left and right, those are audio connections. Connections on the top and bottom of a block are logic signals. And this lets you kind of do basic binary logic. You can have AND gates, OR gates, you can have logic delays, all this kind of stuff, and you can chain it all together and make some sort of logic circuits. So what we have here is if this audio senses this duck signal, and the signal's been present for 10 milliseconds just to stop it accidentally kicking in if there's any interference, this block here outputs a logic level of high, which comes into the ducker and turns the ducker on. So this is fairly simple, similar idea to that sense input. If a notification plays, this will turn the ducker on. Then if the notification goes away, we have this debouncer off delay of 2 seconds. So if the notification goes away, we'll wait 2 seconds to make sure the notification is definitely finished. And then at that point, this logic output goes to low and the ducker will then release. So that allows us to automatically enable and disable the ducker based on the notification. Then in the ducker here, I've got it set that the attack time is 500 milliseconds. So it means that the ducker takes 500 milliseconds to dip the audio down before it's at the lowest level it would normally be at. The problem is, as I mentioned before, if I play a notification immediately and pass that straight through to the output, what happens is the notification will start playing before the ducker has had time to fully bring the volume down. So for that, I then have this delay here. So the notification comes into this delay, the notification is then delayed by 500 milliseconds, and is then mixed into the output. So this mixer takes my source in and out, my notification, and then mixes it all in. And then this here is how you map the different input channels to output channels in a mixer. So that was a look at my configuration for bedroom 1, and this is the sort of simplest configuration you're going to get for any of my rooms. But what's really good with separating everything to different partitions is I can add different customizations depending on that room's setup. So bedroom 1's very simple, just stereo input, stereo output, nothing complicated there. But on the other hand, we have my ensuite bathroom. And because it's a bathroom, I've not been completely silly and put loads of speakers in, there's just a single speaker in there. So all I have here is very similar to before, but I've added this downmix block, which is just a little mixer that downmixes the stereo input to a mono output, and then sends the mono output to the single speaker that I have. Very simple, it just means that I can actually still get proper downmixed stereo rather than only having one channel in that room. So that's all that I've really done here, very similar, just downmixes stereo to mono. And then finally we have probably the most complicated room I have, which is the kitchen dining room, because in here we've got a fair bit more logic. In that room I have 4 ceiling speakers, 2 over the kitchen area, 2 over the dining area, but it is just one big room, so the speakers are all audible at the same time. So as you can see here, very simple, source comes in, same auto ducker stuff as before, exactly the same, and then over here we have the outputs. We have the outputs for the kitchen speakers, outputs for the dining speakers, the sub we'll talk about in a second, and again a meter that shows the signals to all 5 speakers in that room. What I've then done here is I've added in this router here called the speaker layout router. As you can see here, we take a stereo input and the outputs go out to all 4 speakers. Essentially all I can do here is just switch which input is mapped to which output. So I've got my left and right input here, and I can route whether which channel left or right is routed to each of the outputs. Essentially, I've just got this set up, so depending on what way I'm facing in the room, if I'm facing the TV or if I'm facing sort of out towards the garden area, different positions where you're kind of facing 90 degrees, I can flip which speakers are doing stereo. You don't really need it. It doesn't make a big difference, but I can do it, so why not? So that's kind of what that does there. And it really goes to show the power of Tesira that you can do things like that. You can kind of just completely reroute the signals to all your speakers with a simple block like that. It's really, really cool. And then, as I also mentioned over here, we've also got a subwoofer in the kitchen. So for that, what I've done is we have the input comes in as before, and I've then created a couple of crossover blocks. So the input comes into these 2 crossover blocks, one for the left channel, one for the right channel, and then we have some frequencies set in here. So as you can see, we're set the crossover frequency in the kitchen at 80 Hz. Then anything above 80 Hz is sent out the high outputs, and those high outputs then come into this mixer here and get routed to the ceiling speakers. And then the low frequencies then comes out of here, then is down mixed to mono because it's obviously a mono sub, and then is routed out to the sub. We've also got a sub level adjust here, it just lets me adjust the volume of the sub so I can kind of adjust the bass level. You'll also see this comes through a high pass filter, which sounds wrong, sending the audio to the sub through a high pass filter. As you can see, this is set to 40 Hz. It was something I saw in the manual for the sub that just says that they recommend having a 40 Hz high pass filter on the input to it, so I put that in. It probably doesn't make a huge difference, but I added it. Then the final thing we have here is another router here called the sub bypass router. This just lets me switch the sub on or off. One output goes via the crossovers and routes all the audio to the sub and stuff like that. The other 2 outputs just send the audio straight into the output and completely bypass the crossovers and the signal path that sends audio to the sub. So yeah, that's a run through of all the partitions. And now the final thing I'll try and explain, this is going to be really hard, is all this stuff here that I kind of said I was going to sort of talk through later. And this is how I'm handling the amplifier triggering. As we saw when we looked at the hardware, I'm using one of the logic outputs on the Tesira that triggers my amplifier via its 12 volt trigger inputs. So I needed some logic in Tesira that could trigger that output based on whatever's happening. Now, one option I could have is have some way from Home Assistant just to manually trigger that output on and off and build that logic in Home Assistant, but instead I thought I'll still work with audio sensing. That way I don't need to worry about making sure I'm turning the amplifiers on and off. If there's audio playing in any of the outputs, the amplifiers turn on. If there's no outputs playing any audio, the amplifiers turn off, and it's just completely hands-off, completely reliable. So to do this, what I do is in each partition, you can see we have this section here, which is a signal presence detector. There's some additional logic in here we'll skim over right now and we'll talk about later, but essentially the audio comes into the source present detector, which is a signal level meter, or signal present meter I think it's called, and we have 2 different signals here. If there's a source playing in that room, these 2 little signals here light up blue, and that also passes a logic output here. So if there's a signal present on these inputs here, the logic outputs here will go high. So this is for the source, the media playing in the room. This then passes into an OR gate, so if either channel is playing audio, we pass out high, and then that, ignore all the other stuff, this passes out of this block. So essentially, this block here, if there's music playing in the room, it returns a logic level of high. and that is then transmitted through this partition connector. We then have this partition connector that receives those logic signals from all the different rooms. So as you can see here, I've not got all my zones set up yet, but each zone has a single connection into this, so the kitchen, dining, bedroom 1, ensuite, hall, landing, and so on. If each of these zones is playing audio, that will send a logic level into this signal receiver, this logic receiver here. So each of these logic outputs will be either high or low, depending on if that particular room is playing audio. Then we have a delay here. This just sets up that it has to wait 30 seconds of silence before it outputs that room is now silent. It just means that if you briefly pause music or there's a pause between songs or something like that, it doesn't immediately start turning things on and off. We have to wait 30 seconds of complete silence before we decide that output has no audio in it. We then pass all those outputs into an OR gate. This just ORs them all together, so if any room is playing audio, then this outputs a logic level of 1. We then have this delay block here, which has a further delay of 60 seconds before we turn the amplifier off. This just means I'm not turning the amplifiers off unnecessarily. And then the output of this essentially is whether the amplifier should be on or off. Then the output of this then comes down here through some more gates and then into the trigger out section. And this here is the physical port on the Tesira. So whatever logic signal is passed into this is mapped to port 1 on the logic card on the Tesira. As you can see, there's 4 different logic outputs. So with all this logic here, if a source is playing music, we get a logic level of 1 here, and that sends 5 volts out that logic output, which gets converted to 12 volts, turns on the amp. If there's no media playing, we wait 60 seconds, this goes to 0, that output turns off, 5 volts goes away, therefore 12 volts goes away, and the amplifier turns off. Hopefully that makes sense so far. So this setup all works perfectly. However, audio sensing doesn't work for notifications. If we play a notification in, the amplifier then gets turned on when it sends the audio. The amplifier maybe takes a couple of seconds to fully warm up, and then at that point the notification is kind of halfway through. So that's not going to work. So instead, you'll notice we have this block here for notify amp trigger with delay. And this is how I'm handling the amplifier. I'm handling it separately from the rest of the audio triggering. So all that logic we looked at so far just handles turning the amplifiers on and off when music or whatever source is being played in a room is detected. We have additional logic that triggers the amplifiers for notifications. So we have the 2 notification inputs here, they've got their own meters so I can monitor them, and they feed into this custom block here. The output of this custom block then gets routed to all the different rooms by the notification routing, and then that's the notification input in each partition. So this is where all the interesting logic is. And if we open this up, this is not going to be fun to explain because I've not scripted any of this, so this is an adventure for me to figure out how I explain my chaotic setup here. So as you can see, we have the 2 notifications coming in, and then we sense the notification. So if a notification is sensed, if a notification comes in to this block, and it's either notification with this OR block, we then have an output here that comes out of the block, and that is then passed down to trigger the amplifier. So if a notification is sensed by this block, it turns the amplifiers on. If the notification goes away, after 30 seconds, the amplifier will turn off. All hopefully makes sense so far. But then what we have is this section here that delays incoming notifications. I've worked out roughly that the amplifier takes about 2 seconds to fully warm up if you trigger its input. It does start outputting audio a little bit earlier than that, but it kind of does a soft start. So if you start playing a notification within, say, a second of turning the amplifier on, you kind of hear your notification coming in quite quietly and then slowly ramping up volume so it doesn't sound right. So what I do is I want to delay my input by 2 seconds. That way, the notification comes in here, immediately gets sensed and turns the amplifier on, and then we delay that notification by 2 seconds to give the amplifier time to warm up, and then we send the notification to the output and it plays in the room. That way, you play a notification, Home Assistant immediately starts playing a notification, that triggers all the amplifier to turn on and everything, and then the Tesira delays that notification by 2 seconds, then outputs out the output, meaning that the amplifier's had time to warm up. And that all works really well. But of course, what if there's already something playing in one of the rooms? There's no point delaying every notification by 2 seconds, because if I'm already playing music, the amplifiers are already on, the notification can be played immediately. And that's what this additional logic is here. What we have here is we've got the 2 different routes of the signals coming in, either the normal signal that's not been delayed, and then the delayed signal here. We then have these 2 mute blocks, we have mute delayed and mute normal. We have a logic signal into here, so if this logic signal is high, we mute the delayed input, and then go to a NOT gate, so then we unmute the normal input. If this logic signal goes to low, we unmute the delayed input, and then we mute the normal input. And then what we're passing into this logic signal here is the amp ready status. So it's the output of these blocks here that basically says whether the amps are already on or off. So if the amplifiers are already turned on because there's music playing, then we route the normal notification through to the output. If the amplifiers are already turned off, there's no music playing, then we delay the output. So yep, it all works. But you might be looking at this and thinking that there's one slight thing here, is how on earth do I configure this? Because surely I'm not going to be sort of on an ongoing basis going, oh, I want to play music in the ensuite, so right, I'll go into the Tesira software on a Windows machine, come into here, click a bunch of things. Oh, I want to update the volume, cool, I need to come into here and then go into this level block and adjust the level. Yeah, that's not how you're going to use this on an ongoing basis. But with Tesira, it's actually really easy to control it with other systems. With Tesira devices, you have what's called the Tesira text protocol. And this is just a simple telnet protocol that you can use to send commands to a Tesira device. And essentially, you can use TTP commands to basically configure any of these blocks. If you've got a level block, you can adjust the level. If you've got a router block, you can adjust how all these different sources route to each other, all that kind of stuff. It's incredibly powerful. Similarly, if you've got things like a logic meter here, you can read the logic levels. And that's what this is here. We sense the outputs of all the zones, and then we read whether each zone is playing audio into Home Assistant. So if a zone's been turned off and it's not playing audio for a while, we can set that input in Home Assistant back to its default value. We'll talk about that in my later video when we go through the full setup. But the Tesira text protocol is incredibly powerful. There's a bunch of documentation here that explains it all, but the best resource I found for it is the Tesira command string calculator. And what you do is you pick the block you want to control, for example, a level block, like that. We then pick what attribute do I want to change, so I want to change the level's level. I want to set it so you can get the value, or if you want to read the level, or you can set it, or you can increment, decrement. We then set the channel here, so I'll just set that to 1. You could have multiple levels in a single block. We want to set the volume, we can set the new volume, so I want to set the volume to, you set that to -12. The leveler block then has a name, so as you can see if we come over to my Tesira software here, each block has a name, so for bedroom 1, the leveler block is named B1_level, so each room has its own kind of unique identifier for its level control. We can then come into the command string calculator, set that to say B1_level, press calculate, and it gives you the string. So B1 set level 1 for input 1 to -12. And then we send this to the device using a telnet connection, and it'll just take that output, configure that level, and it just works. Now, for my setup here, I've got all this configured in Node-RED, so we have some setups here for source selection, for example, that we have signals coming in from Home Assistant. It goes through a bit JavaScript that maps all the inputs and outputs, generates a command. We then generate that command, so source router set input. This is the Tesira text protocol commands that get generated, and they then get passed over to Tesira here. Now, I'm not going to go into full detail on that in this video. I'll probably go through it more in my final video in the series, and I do want to do some dedicated Node-RED Home Assistant type videos as more tutorials, but that's kind of how I've got mine all set up here. But it all works. I can start music playing on one of the source devices. I can then send the Tesira a command to route that particular source input to the particular room I want to listen to the music in. And if I want to adjust the volume, I just adjust the level in Home Assistant. That sends the correct level command to the Tesira. The Tesira then adjusts the level in that room. It all works perfectly. And then if I want to trigger notifications, all I need to do is send a TTP command to the Tesira that adjusts the notification router here to route the appropriate notification input to the appropriate room I want to play the notification in. I then set Home Assistant to play that notification, either a sort of pre-recorded chime or maybe a text-to-speech notification, and then set it to play that to the correct notification output that gets routed through here, gets routed to the correct room, it triggers the ducker to duck the volume down, and the notification plays in the room. It all works perfectly. And with that, we have the Tesira up and running, and it all works perfectly. So hopefully you found this video interesting if you're potentially considering getting a Tesira or you just want to see how my setup works. But that's all for this video. It's already gone on long enough. In the next video in the series, what we'll then do is take an in-depth look at the Dante audio over IP system I'm using to get audio from the TVs around the house into the Tesira. We'll take a look at how all that works. And then in the final video of the series, we'll take a look at the completed system up and running, how I'm controlling it through Home Assistant, the interfaces I've built, and then take a look at some live demos of it all working. But yep, hopefully you found this video interesting. I appreciate it's been a very long time since I said I was going to do this video. It's very long overdue. But all I've left to say now is thank you very much for watching.